Okay, there's some more problems from section 9.5, and this is number 43, and we have this series as n goes from 0 to infinity of n times x plus 3 to the n over 5 to the n. First of all, we want to check this. We're going to check for all the three things we talked about on all the problem sets. I want to find the interval of convergence, where it's absolute convergence, and any points that are, or any values that are conditionally convergent. So first of all, we use the ratio test to test for absolute convergence. I'll take the absolute value of this limit. This is the ratio test, a sub n plus 1 over a sub n. So I'll take the limit n plus 1, n plus 3, the absolute value of n plus 3 to the n plus 1 over 5 to the n plus 1. This is the a sub n plus 1 times 5 to the n over n times the absolute value. So this is just going to be inverting this, and we're taking the absolute value of just the x terms because the n's are always positive. All right, so we're just going to invert this. So this is 5 to the n, and this is over n, and that's the absolute value of x plus 3 to the n. And then I can break this up, so I have n plus 1, and this is going to be x, the absolute value of x plus 3 to the n, times the absolute value of x plus 3 to the first, that's your n plus 1. And 5 to the n times 5, that's your 5 to the n, 5 to the 1. 5 to the n, and then we have n plus 3 to the n. Same thing, this just comes down. So now I can cancel the 5 to the n's, and I can cancel the x plus 3, the absolute value of x plus 3 to the n's. And I put my n terms together, so I've got n plus 1, n times this 5 plus x plus 3 over 5. Okay? And if I take the limit of this, this is just going to be 1, so it just ends up being this, which equals L. This limit equals L, and that converges absolutely when L is less than 1. And that's just going to be just this. So it converges when the absolute value of x plus 3 divided by 5 is less than 1, because this whole thing is L, and this just ends up, this limit goes to 1. I'll probably notate that like this. That goes to 1. So we just have this. So then we multiply both sides by 5, and we get this. This is actually our radius of convergence, which is 5. And then we'll just break this up, so negative 5 to 5. Then if I add, subtract 3 from both sides, it's going to be 2. And that's going to be a negative 8. Now the distance between negative 8 and 2 is 10, so you can see how right in the middle of 10 is 5. So that's the radius of convergence. Half of 10 is 5. Okay, so this is where it converges absolutely. Pardon me, let me get this down here. Sorry about that. So again, what I did was multiply by 5, and this again was the radius of convergence, and then I break this up. So this is negative 5 less than x plus 3 less than 5, and then if I subtract 3, I get negative 8 and 2, and then like I said earlier, the distance between negative 8 and 2 is 10. Half of 10 is 5. That's the radius. So it'd be kind of like you might call that the diameter. Converges absolutely on this interval. So we know it converges absolutely on this open interval, but we want it for the so therefore it converges, because if it converges absolutely, it converges. So it converges on this interval. So I have to remember that. But we want the interval of convergence, so we also have to check the endpoints. Okay, and that would be at x equals negative 8 and x equals 2. So we have to check those endpoints. So all I do is I put those values back into the original series. It goes way up here, this guy here. I'm going to put negative 8 in here and see what kind of series I get, and I'll put 2 in here. So there's a series without x, and those are kind of like the problems we were doing earlier. And we know how to check those for convergence. And then we'll get some kind of conclusion here, all right? So we'll check the endpoints. Okay. So at x equals negative 8, I put negative 8 in here, and I get negative 8 plus 3 is negative 5. So I get n times negative 5 to the n over 5 to the n. I could take out the negative 1. All right, and that just leaves you with, and then I would just have 5 to the n. So I didn't show that step, but I hope you can see that if I make this as negative 1 I could write this above here, this so you could see this. Some of you need to see this. Would be the same thing as -1 to the n, all right, times 5 to the n. So I could write this like this, and then see the 5 to the n's would cancel. All right, so I would have just left n times -1 to the n. Well, if we look at the term, the nth term convergence or divergence test, actually, as remember the limit in order for this series to converge, the limit of the nth term has always got to approach 0. Otherwise, it's not going to converge. So if I take the limit of this as n approaches infinity, it's going to actually oscillate, but so it's not going to ever approach 0. So it's not going to converge. So it must diverge by the nth term test because that limit is not equal to 0. Okay, like the limit of 1 over n is equal to 0. No problem. This definitely. I got infinity, and then I've got oscillating -1, +1. So don't know what's going on. Okay, so this n is going to go into 0. So that's that. At x equals 2, if I put 2 in here, this is a little bit easier to see. 2 plus 3 is 5. So I got 5 to the n. Those cancel, so I just have this, and that definitely does not converge. That's easier to see. If I take the limit of the nth term as n approaches infinity, it actually goes to infinity, not even a number. And any number, it's not going to work. The only one that's going to work is 0. It must go to 0. So that also diverges. So my endpoints diverge. So they're not in the interval convergence. So the interval convergence is open. So it converges absolutely, which means it converges. Remember, absolute convergence implies convergence. So it converges on this interval, -8 to 2. That's the interval convergence, and that's also the interval in which it converges absolutely. So there are no values of conditional convergence. There are no values where it converges but not absolutely. These are the same. Okay? So think about these. They're all basically built off of these. So you should be able to start handling these on your own.